just hold it up. It's not working right. You can use these. Just don't point it down. They don't like that. Shall I just give her? Yeah, we're good. You guys all set? Yeah. We're all set. All right, you guys all set? Yes. Just wait for things to quiet down a little bit. I know. All right, I'll start by introducing myself. I'm Tim Weber. I'm the new tech support staff here at NextEnergy. So when you call in looking for help, I'll be the guy they direct you to, and I'll do my best. I've been here for 2 weeks. Been in the industry for about 10 years, not specifically geo, but HVAC industry. So I'm still learning as well. Learned a lot in the last 2 weeks, actually, just talking to you guys, last 2 days, actually. So today we're going to go over a little bit about troubleshooting the units, things for you to look for. Refrigeration cycle, I know a couple of you guys have mentioned it's not quite your expertise, so we're going to try to sharpen your skills on that. I'm going to start off here. This is a little bit of basic refrigeration here, some thermodynamics, I guess you'd call it. This is how a heat pump actually works. Just gonna get this started. So what you see happening up here is your compressor, compressing the refrigerant into a hot, high-pressure gas, which is your discharge line. And what's happening right there is it's going through the condenser, condensing into a liquid. Oh, this thing's moving pretty fast. Anyway, it's coming through the condenser, condensing into a liquid, through the liquid line, which is where your thermistors are mounted, through the expansion valve, pressure drops, temperature drops, going through the evaporator, and back into the compressor. Now this part right here, and this part right here, that's what's doing all the work in a refrigerant cycle. That's where you're getting all your latent heat. That's why heat pumps are so efficient. That latent heat, it's a kind of a natural way of extracting or producing a lot of heat. Anyway, yeah, that's your basic refrigeration cycle.
These could change as we reverse it, eh? One's your coax, the other's your evaporant, and they change back and forth depending on what we're doing, eh?
Right, well, I'm sure you know the evaporator is what removes heat either out of the water coming from the loop or removes heat from the air inside the house. And the condenser is what rejects heat either into the water from your loop or through the air coil, putting the heat into your house. So it's all about transferring heat from the ground to the house or from the house back to the ground. And this is the cycle that makes that happen. Sure.
Because he's got to leave.
Okay.
So let's just
Scroll through.
tell him that.
We're just going to move ahead a little here so Dan can do a little presentation before he leaves. And just to let you know, unfortunately, Jeff Hamill from Climate Master, he actually was going to be up here with me. He actually was going to do this, but he had a unfortunate family situation he had to go home to, so here I am, my first time speaking in front of a group of people.
Winging it. Okay, Dan. No. You're not sitting in the crowd. Come here. Get up here. Bill.
just want to talk about the CMX board a little bit?
Yeah.
Before we get out?
Go ahead. I mean, just,
One more time.
I've definitely not seen this slideshow, so I don't know what's on it.
It's not serious.
Okay, so basically we're just showing our control box layout and how handy it is. And of course, the main part of all our units is what we call the CXM control, and pretty much kind of stands for compressor control module. But it handles all the safeties and everything for the entire unit. There's, I think, like 8 possible things that it's monitoring. You've got your contactor, you've got your pump circuit breakers, transformer, your loop pump connections, and then if you have a variable speed fan, you get the ICM fan board, which I told you, and that is where your thermostat connects, by the way. And our new board, how many of you have used one of these boards right here? The new one, you can pull the thermostat thing off in your hand and wire it, and then plug it back on. You'll enjoy that little feature too. So you don't have to like do it laying down there.
Don't need a magnifying glass.
Right.
Back to that one.
Okay.
That's a 3-phase contactor, so you only use 2 sides?
Yeah, I think probably just they're doing it economy of purchasing.
I know, but just show them like
Oh.
the wires where we gotta make.
Oh, sorry, yeah. Is that where they're supposed to see all that here? Yeah, there's your line voltage connection. The contactor is the line voltage terminal block. So you wire right into the contactor, and you wire your thermostat there, and you wire your loop pumps there, and they're fused or breakered actually. There's also a low voltage breaker for the protect the transformer. Capacitors right there. Everything's right there.
What I wanted to say was that line voltage where it comes in. Where? How do you do this? Where do you do this?
Push that yellow button.
Right here where the line voltage comes in, there's only 2. This is a 3-phase, so we only got 2 spots. So one thing to make sure is that you line up and don't move one of these lines over to this side because you got no feed going out
Nothing will happen.
and nothing will happen, so you won't. So I'm just saying, like, there's 3 spots you can hook on. Make sure you line up with these 3. Go ahead, your turn.
Okay. Good point. Okay, so this control,
I've done it.
you've done it?
Yeah.
Okay, I wouldn't admit that if I was you.
Well, I've seen it.
You've seen it done. That's a good way to do it. So this one board runs all our products, so that's all you're going to see in our residential units is CXM, unless you buy a Climatar unit, and then it'll be upgraded to the DXM board, which is a bigger board with a lot of commercial features on it, but it also has the ability, logic, to do things like dehumidification mode. So there is a DXM control, has exact same safeties. It just looks bigger and has more stuff. You may see that someday, but basically 99.9% of residential product, 100% today, has the one board. So you only got to carry one board. We got some nice features on there. One is a unit performance sentinel. I never recommend that you use our unit without, I like you to use our thermostat. First off, most people, that's the only thing they know about the HVAC brand is what the thermostat says on it. And but our thermostats are designed, they all have a fault indicator. If you don't have a fault LED, then you're going to miss out on a whole bunch of the features of our control. The homeowner will, and actually it's to your benefit too. One of them is the unit performance sentinel. If there's a problem with the system, but it's not locked out, it's just not running efficiently, it'll actually kind of blink and let the homeowner know that something's up. And they may call you and you say, what's it doing? You say, well, it's blinking kind of slow. You say, oh, well, it could be anything from a dirty filter. Okay, so basically what it's sensing is that the condensing and evaporating temperatures are not normal for the unit. And it probably will talk, I'm assuming it's going to get into more detail on that here as we get into this show. There is a fault protection, or there's a fault memory in it. So if the unit does lock out and the breaker hasn't been reset, it doesn't remember it doesn't have a battery, so it won't remember if power's been off. But if the breaker's not been reset, it'll remember the last reason the unit locked out. And then there's some accessory relay terminals to provide for air cleaners, humidifiers, water valves for a well system. Okay, some of the features that we have on the safety, we have a high pressure switch that ties in. We don't use a low pressure switch, we use a loss of charge switch, because what we're trying to, that's really what you're trying to do, is protect the compressor from running and overheating due to no refrigerant in the system. And so, low pressure switches are not very good freeze protection devices. Some people have done that, but they are not, you'll freeze up your coil by the time you trip a low pressure switch. So one thing that has confused people is where our loss of charge switch is. I've had a lot of people say, you guys really screwed up, your low pressure switch is on the hot gas line. And what's going on here? What we do is you don't want nuisance trip outs. If you put a low pressure switch in the low line and you have a drawdown at the beginning of the cycle, you can get a nuisance trip. So we just found that when you have systems that are splits, whatever, where you don't know what's going on in terms of that, if you're trying to just do loss of charge, all we do is we look at it when the unit is off, not when it's on. So if there's a thermostat call, the first thing the board does is look at the loss of charge switch and say, do I have charge? So it looks when the compressor is off, not on. And I can't remember the setting of the switch, 40, 50 pounds, something like that. It just got to be a static charge in the unit of 40 or 50 pounds sitting there. So as long as it's above that, it'll say, fine, go ahead and run. So keep that in mind. It's a low pressure switch on the high pressure side, but it's only looked at, it's like a little test. Call for a thermostat, check that switch. Got charge, go ahead and run. Once it's running, it never looks at that switch, except that we did build in, I think it's every 2 or 4 hours. I think it's 4 hours. 2 hours? 4 hours? 3 hours, okay. If the unit's running steady for 3 hours, we want to make sure that we didn't lose charge. Let's say you had a catastrophic leak. A fitting blew, you lost all your charge. You wouldn't want the unit running then for days and days and days and never shutting off, and then the compressor burns out. So every 3 hours we stop just for a couple minutes. It probably takes a 4 minute because of the time delay. Stops, says, hey, do I still have charge? Yep, goes again. Now that would you'd ever see that is if your unit's been running steady without shutting off for 3 hours. But that's how we do this. It's worked really well. We have high and low voltage protection. If the voltage gets too high or too low, the unit will stop operating until that condition corrects itself. It's not really a lockout. It'll come back on when the voltage comes back in line. Yeah, it's in the board. And we had it pretty tight, and then we found out there's all kinds of crappy power out there, so we had to loosen things up a little bit because we had units, a lot of overvoltage stuff going on. So we kind of loosened the parameters a little bit. Basically, it looks at the voltage coming out of the transformer and does it that way. Do you guys have 240 volts? Is that what you typically have? If you would ever accidentally have the transformer on the 208 volt tap, then you'll have real high, low voltage coming out. It'll make it jump up. Instead of 26 volts or whatever, you might have 30. I think it's around 30 volts where that thing would start tripping. So, if you do have an overvoltage, first thing you might check is to make sure your transformer's on the right tap. Yeah, condensate and he's saying it's orange and red? Okay. Condensate overflow sensor, that's electronic. In the cooling in the drain pan, if the water reaches that wire, that sensor, it's really all it really is like a terminal. If it reaches that bare terminal, shuts off the unit in cooling. This is a lockout. This is a lockout. This is a lockout. This is kind of it just stops until the voltage corrects itself. There's anti-short cycle. So you can't short cycle the compressor. You might say, wow, it's kind of, it's good overall, but it can be frustrating at sometimes. But we got a way to speed that up if you're working on the unit and pretty well knock that out of your way. We have air coil freeze protection and water coil freeze protection. There's basically the same sensors that are providing this UPS. They're basically monitoring the evaporating temperature and the condensing temperature in either direction, but essentially, in this mode, it's looking and saying if the air coil freezes up during cooling, then it'll shut the unit off, lock out. If the water coil freezes up, shuts the unit, locks out, or just before it freezes up. Then the UPS, like I said, and I think there should be a table coming up that maybe tells you what would cause a UPS, Unit Performance Sentinel, but it basically looks for abnormal temperatures on these two sensors. That's all it's looking at. is these two sensors, and it has different parameters it looks at depending whether you're in heating mode or cooling mode. Let's see, a diagnostic LED on the board. People have said, geez, why not have it on the front of the unit? Well, the reason we don't, because a lot of times the units are not that convenient, and we have a way in our board that you can see at the thermostat the reason for the fault, which hopefully will be in this slideshow here in a minute. Yeah, fault readout at control board or the thermostat. So if you're at the board, you just count the number of flashes. That'll tell you the cause of the fault. If you're at the thermostat, you can do this over the phone with the homeowner. They're calling you up. My unit's shut off. You know, the fault light's steady, locked out. You just tell them, okay, you know, turn your fan off and on 3 times. If you do that 3 times within a minute or 2 minutes, can't remember the exact parameter, the unit will go into a mode where it then blinks the fault code right at the thermostat. Kind of a handy feature. So you can read it right at the stat. It has fault retry automatically, so if it trips out on any of these things, it'll try again on its own. Different ones are different. It tries, I know high pressure it'll try, loss of charge it'll try, it'll check. I mean, it won't even start there. Condensate it would probably try. The only one is water coil freeze protection. I think we build in some stuff, and I don't, you know, hopefully it'll be coming up in here. We made some changes to that. It usually tried 3 times, but then we developed a new way of doing it, and I can't remember if we, you know, hopefully this show will tell you. We actually came up with a real intelligent freeze protection thing that we didn't want to necessarily do that 3 times. But there's a switch, you can turn it on or off, whether you want it to or not. And intelligent reset. I'm trying to remember what that is. Intelligent reset. Well, it just basically, if you reset at the thermostat, there's still a fault remembered.
And next time you turn it on, it shows the fault from the last.
Yeah, that's the fault memory. Yeah. Okay, your fan speed selection is from the control board in there, and we add on the fan board some LEDs to tell you what the thermostat is calling for. So you can see, you know, Y1 is coming, Y2 is coming, G is energized, O is energized, so you can see what the thermostat is calling for on the fan board, which is just handy. I mean, you might say, why don't you put that on every unit? Well, if you got a deluxe unit with the variable speed fan, you get the full board features. More basic units, that adds a considerable amount of board space and cost, so we didn't put it on every unit. So it's part of the higher end units. You get to pick your CFM, heating, cooling, and auxiliary heat. You get to decide whether you want to run in dehumidification mode or not. If you turn that on, the unit runs on a lower airflow and cooling to dehumidify better, which up here, I think you would use that. I don't know why you wouldn't want it all the time. And it does tell you the airflow you're running at. The thing will actually blink, this little LED, 1 flash for every 100 CFM. So if you wonder what airflow it ought to be running at, you know, if it's blinking 12 times and it's off for like 20 seconds and does it again, you got 1,200 CFM. I don't know if we're getting more into this board here or not. Really? They don't get into more detail on that? Okay. I think these guys can handle all this, because I know I got to.
What about that UPS Sentinel? What's the parameters on that?
Well, I was hoping that would be in this show, but I don't have the show. I haven't seen this show.
If you had a cold roof, you could get nuisance fault with UPS.
You can turn UPS off if it ever causes you any problems. It doesn't lock the unit out. Unit Performance Sentinel does not shut the unit down. It just kind of blinks the fault light. I just was going to see if there's more in this slideshow on this. If not, so this.
What do you want?
I just don't. I don't.
Do you want an IOM?
An IOM has all this in it.
Yes, sir. We're done?
I think I've pretty well covered it. Okay. Basically, there's a big page or two in the IOM that goes through every one of these faults, what temperature is really at the thermistor. There's a little summary of this on the wiring diagram.
That's 1 second. I've got it right here.
Yeah. You can see a lot of this information. This page really should be part of this training, but you've got all the stuff that I talked to you about on modes of operation. Test mode, there's 2 pins on the board. You can either stick a screwdriver between these 2 pins, or I just stick my finger and I'll do this and just hold it on. You can't get shocked, well, unless you put your finger in the wrong place. And yeah, not on that board you're not going to, but if you stuck your hand in the contactor, I mean, you know. So you just short those terminals for just a second. It throws it into test mode. Test mode speeds up all timings by 10 times. So, and then it also tells you the last fault. It'll start immediately clicking what caused the last fault. On the fault LED, it'll actually start flashing the last fault. And it will also flash it at the thermostat at that point. So when you, yeah, there's those pins. There's the 2 pins, and they're just 2 little metal pins that stick out. So you just momentarily short them. And then there's the dip switches, which I think there's 5 on here now. This is an old drawing. We had used to have clippable jumpers down here. There's 5 dip switches now. Real important here is the freeze sensing. It comes shipped for well water. And if you hook it on a loop, you want to go back to that? You got to clip the jumper for FP1 if you're on a loop. If you don't, I mean, you're going to have nuisance trip outs on freeze protection. Yeah, FP2 is for the air coil. Don't clip that one. Just clip FP1, which is the freeze protection for the water, and that lowers the set point for antifreeze loop systems.
One other thing. Sometimes we sell refurbished units. Make sure that that isn't clipped if you're putting it on a well water system.
You can solder it back together
Yeah.
or whatever. And you're
In
back.
fact, that may be something we'll do if we refurbish stuff.
You probably
Solder
should.
it back together and it's done.
Probably be a good idea. Your LED should be shown on here, but it's on the board somewhere here. Yeah, well, that's the DXM. Yeah, there's the LED. There's the test pins. There's the dip switches, and there used to be 3 jumpers you could clip. We now just have 5 dip switches. And that's really for some commercial features we stuck on here. You really don't need too much of that for residential. There's your jumpers for FP1 and 2. You really would never use FP2 unless it'd be a real strange thing you would ever clip that for. And that's pretty well it on that. Let's go back to the table or the IOM. Let's go through a few of these. Okay, so what happens when you go to test mode? By the way, when you do the 3 Gs on and off at the thermostat, that's the same thing. You're throwing the unit in test mode. So you can be standing in the house at the thermostat, not want to wait that time delay. Just turn the fan on and off 3 times, get it thrown into test mode, and you don't have to wait on time delays. You don't have to run back to the unit to do this. You can short those 2 pins, or you can do it at the thermostat. And that'll last for 20 minutes, test mode, and then it automatically goes back into normal operation. Or if you wanted to go out of test mode, just do it again. If you short it again, it goes out of test mode. Or at the thermostat, hit G on and off 3 times again, goes out of test mode. All things are sped up 15 times, sorry. So if it was 4 minutes, which would be 240 seconds, it'd be 15 times faster than that. The status LED will then flash a code representing the last fault, and the alarm relay, which is the fault LED relay, cycles with that LED, which means it signals the exact same thing at the thermostat. Any thermostat that has a fault light, yeah. Any thermostat with a fault light. Now that status, if you're not in test mode, the status LED indicates what's going on. And go up a little higher on that thing. Okay, retry mode. If it's in a retry period, you're just going to see a slow flash, 1 flash every 2 seconds on the board. So if you're working on the unit and the compressor stops, and you see this LED just flashing really slow, it's had a fault trip out, and it's in a 4-minute delay where it's going to try again. There you get your freeze protection FP1. It's either 30 degrees or 10 degrees. So 30 degrees for water, 10 degrees for loops. Alarm relay setting is a dip switch. Well, here's a jumper, sorry. Yeah, jumper on the board. It's automatically wired to give you 24 volts to the fault LED. Occasionally on commercial systems, they want a dry contact fault so they can do whatever they want with their control. Then you clip that and it knocks the 24 volt off, and now you just have a relay that closes a dry contact for faults between the terminals AL1 and AL2. There's your dip switch. You can turn off the unit performance sentinel. So if that thing is causing you any kind of grief with the homeowner, that because you have an unusual system where what we think is abnormal is what you call normal, you can turn it off. And the next dip switch is we use it for two compressor units. So it puts a little delay between stage 1 and stage 2. And then some of your notes on the flashing is a slow flash is 1 flash every 2 seconds. A fast flash is two flashes a second. That's a rapid flashing. And then you got your codes. So let's just see what happens to your normal mode. When you walk up to that board, that LED is just on. Green light, steady. That means everything's fine. If there's a UPS alarm, and oh, by the way, then the fault light on the thermostat, it's open, so nothing's happening. So basically, if everything's normal, you go to the board, you're going to have a steady green light, and the thermostat light will not be on, okay? If it's got a UPS warning, which means what I told you, that we think the unit's operating abnormally, you go to the board, that light is still on green because the unit is still going to run. Everything's acting fine, but there will be a 5-second fault light and then 25 seconds off. So they'll just see this random kind of hit on their fault LED. They'd wonder what it is. It just means that your unit might need service. It's kind of like a service reminder. You know, most common cause of this is dirty air filter, which would raise the condensing temperature. Then you got, if the LED is off, that means your board is bad or you got no power. So that should never happen. So if you see a dead LED, you've either blown the board or you don't have power. And then during fault retry, I told you that was a slow flash. If the unit locks out, it's retried a couple times and it locks out, it'll just start rapidly flashing. That means your unit is locked out right now. During the over voltage, there's a slow flash. Oh, by the way, when it locks out, the thermostat LED now is just on all the time. So if they have a steady light on their thermostat, their unit's locked out. During the over-under voltage, you get a slow flash at the board, and you get after 15 minutes of it, finally the thermostat will tell them. So if it lasts, it shouldn't last that long, these periods, but if it would, we really don't want to bother people. Or did you need to say something? Or okay, I just thought maybe something was going on. Probably trying to yank me off the stage and get me in my car. Test mode, okay, here's your flash codes, your fault codes. There's 8 of them. And if you're in test mode, you'll see these fault codes and you'll see them at the stat. So if there's no fault at all, you'll just get 1 blink. That means the unit's never had a fault. And then you got 2 flashes, which means you got a high pressure fault. 3, this is the most, well, not this one. 4 is the one that you might see the most. 3 means a low pressure. That's loss of charge. You almost never see that. But if you see 4 flashes, that means you had a water coil freeze protection, which means your pump didn't run or you had some kind of problem. Maybe you forgot to clip the jumper. That's a real common one. If you're on a loop and you don't clip the jumper, it will lock out eventually. Pretty quick in Winnipeg, probably. Then 5 would be air coil freeze. 6 is condensate overflow. 7 is an over voltage. And it's just a shutdown. As soon as that voltage goes back to normal, it corrects itself. And then 8 says that you had a unit performance sentinel event. Again, that's not a lockout.
Yeah, and then you really have...
Then this gets into a whole lot more detail of each one, what causes it. And I don't think I need to go through all those, but if anybody's worked with our units and has a question that they want to talk about.
Freeze protection we're going to talk about later.
Yeah. Yeah. Yeah, that would be the fault indicator on that stat. Yeah, and it'll just do the same things. It'll blink on or off, and it would blink, you know, you can still read it out. So instead, in some cases, instead of a red LED, you got a wrench.
There we go.
Okay, these guys are going to be on their own.
Give me that.
Anyway, I just want to thank everybody for coming and spending 3 whole days sitting through this. It's been a lot of information, and I just really enjoyed being up here, and just want to thank you for your hospitality, and I look forward to hearing good things about all the units that are happening because of this meeting. So, thanks. Oh, yeah. Yeah. Well, you know, the reason I haven't even been to one of these meetings in, I'll bet, 7 years, dealer meetings. You know, I got so many other things I do. So there's only one reason there's 2 reasons I'm here. One is Dave is about my best friend in life. Second is he happens to be the biggest distributor for residential geo in North America. So that's 2 major reasons that I'm standing here today, and I'm glad for both of those circumstances. Yeah. So thank you guys for all your business.
Yeah, we'd like to thank Dan for coming up. They were a big major sponsor of the event. You put on events like this, it costs money, and Dan and Climate Master come through as usual and helped us sponsor the event. We see a great future here where the growth maintains itself the way it is in this first quarter. It's going to be quite a ride. And these Climate Master can supply it. As I said, Dan's basically tripled sales since he moved there. So they can stay with us. That's not an issue.
I know you have to head out, Dan, and I wanted to thank you personally. It's our first chance to get to know each other, and it's been fun. It's incredible when you got senior management from your major supplier behind you all the way, and even better yet, when they really understand the technology that they're selling. I think that's kudos for you, Dan. I hope things are better for Jeff. Let him know we're thinking of him. Thank your team. And also ask them to hang on to their socks, because now we're just getting started. So, I can see that. Thank you very much, Dan.
All right, back to business here. Start off talking a little bit about 410A. Obviously, most of you know it's a very new refrigerant, especially in our industry. How many of you guys have worked with that refrigerant much on the refrigerant side? A couple guys. Actually, let me rephrase. How many guys here actually do refrigeration work? Good number of you. All right. Well, 410A. Most cost-effective refrigerant, most efficient. That's why it's in the new Tranquility unit. COP levels have gone up. HCFC, as you know, they're phasing out all the old refrigerants, including R22. So we want to jump on board, replace the refrigerant before it becomes obsolete. We don't want to be caught. It's a 50-50 mix of R32, R125, no glide, which means technically you could charge it as a vapor. They don't recommend it, especially in smaller amounts. You do not want to charge it as a vapor, but like I said, there is no glide, so it's not quite as much of an issue as some of the new drop-in refrigerants. And next generation of geothermal efficiency levels, and that's, of course, what we're striving for. I haven't really seen this slide either, just like Dan, so bear with me here. Okay, this is just showing a scale on refrigerant costs throughout the years. 1990, $80. 1997, $600. Refrigerant price for automobile service. I mean, I don't know if any of you older guys remember back 30, 40 years ago, grocery store units, they'd take garden hoses up on the roof and purge 500 pounds of gas onto the roof drain just because they thought it was a good thing to do. put in new gas, clean out the old system. They don't do that anymore. That's probably about $6,000 worth of refrigerant. But so it's changed the way we do things. It's changed the tools we have to use. It's just changed the way we think, and it's a good thing. And this just talks again about the efficiency of the R20 or over the R22. The fact that it's not a blend. Con, higher operating pressures, which I'm sure you've noticed, and I warn you guys to be careful with that. Do not put traditional gauges on on a 410A system. You will blow the line, or you could blow the line, and that hurts a lot. Requires new production design, hence the Tranquility unit over here. Piping has to be different. The piping has to be stronger to carry the higher pressures. The coils are different. Everything's different about the unit. Higher caliber service practices required, and we're really urging you guys to either become or have a R410A mechanic either at your disposal or become one yourself, because it is different. It's a lot different than what you're traditionally used to using. I'm sure you realize the oils that are in the 410 are hygroscopic. They absorb moisture at an incredible rate. There'll be some charts coming up later, but if a system runs out of gas, and if it's sitting there for a couple of days, you cannot just pull a vacuum on that system and recharge it. You actually, if it sits for a long enough period of time, you will have to change the compressor. And ClimateMaster knows that, and that's just it's part of the industry now, nothing we can do about it. Okay, again, higher pressures. Now, lower discharge temperatures. I don't know if any of you guys have noticed on the new units for the desuperheater, there's actually a thermostat on the discharge line that's wired in series with the desuperheater pump. The reason for that is with 410, the discharge line can actually run at a low enough temperature that if you try to desuperheat, you can actually take heat from the water heater and put it back into the refrigerant. So if the loop is running very cold this time of year, you do have lower discharge temperatures, lower pressures. The desuperheater may not work, and that's why there's just not enough heat in that discharge line. But that's also why the refrigerant's very efficient, less heater rejection. So, but as a downfall, you cannot always use the desuperheater. Leak detection. Some older leak detectors may not work. They would probably have to be pretty old. Most of the newer leak detectors work with pretty much anything. Requires different lubricants, which you guys probably won't have to worry about unless you're, for some reason, changing the oil, but all heat pumps come with scroll compressors. Obviously, oil comes from the factory. You can't really add oil very easily. And like I mentioned earlier, the POE oil is hygroscopic, and that's probably the most important thing you need to remember. Do not let any air or moisture get in that system. Always change the filter dryer, and work quickly. Do not leave that system open. All right, this is just a little lesson in basic thermodynamics, I guess. Kind of explains actually how refrigeration works for those of you that aren't quite clear. This here represents water. It takes 1 BTU. Well, what a BTU is how much energy required to change 1 pound of water 1 degree. And as you can see here, water is going from 209, 210, 211, so that would be 2 BTUs. But to go from 211 to 212 means the water has to actually boil, and that's our latent heat, and that's where refrigeration is all about. It takes 970 BTUs to go from 211 degrees to 212 because it has to change state. It's vaporizing, and that's what's happening in your evaporator. The refrigerant is changing state, and that's where that 970 BTUs is so important. That's why if the refrigerant's not changing state, if you don't have the proper airflow, proper water flow, and we're not getting the most latent heat out of that unit, there goes your efficiency. I mean, you can see the numbers. Raising the temperature of Freon doesn't do anything. Changing the state, that's where you're getting the workload out of the unit. All right, here's a basic unit running in a heating cycle. Start off with the compressor, through your de-superheater, into the reversing valve. From the reversing valve, comes down, this heating cycle, sorry. Into your air coil, which is your condenser. That's where you're getting the condensing, again, that's rejecting the heat. It's going from a hot vapor into a, we'll say cool, not actually cool, probably about an 80-degree liquid. As it comes out of that condenser, it's 100% liquid into the expansion valve. If it's not 100% liquid here, expansion valve will not work. Through the filter dryer into your coax coil, where it's extracting heat out of the ground. That's now your evaporator, of course, and back into the compressor. That's a basic refrigerant cycle of a heat pump in heating cycle. Cooling cycle, basically the same thing but backwards. It's now leaving your compressor, again through the de-superheater, that doesn't change, into the coax coil, and now we're rejecting heat into the earth, absorbing heat from the house, putting it into the earth, through the filter dryer, into the expansion valve. And again, this right here is now your condenser, and just like the air coil earlier, it's important that the gas is 100% condensed into liquid, and that's where the water flow comes into effect. If you don't have enough water flow, you can't remove enough heat, it will not be 100% liquid. From there, through the expansion valve, this is now your evaporator, just like a traditional air conditioner. Leaves the evaporator, it's going to be 100% vapor. Again, that's also equally important. Compressors don't like liquid. Comes back into the compressor, through your suction line, and goes through again. All right, this is, well, obviously think safety first before you start troubleshooting a unit. Make sure your tools are in good condition. Make sure your tools are calibrated. That's very important. Gauges, check them every once in a while. They bang around in your truck. Before you put it on a unit, make sure it's at 0, both sides. Leak detectors, make sure they're calibrated. Electrical meters, all that stuff. Calibration is very important, especially when stuff's kicking around the back of a van. All right, superheat. How many of you guys know how to measure superheat or have measured superheat? A couple of yous. Superheat is basically, refrigerant has what's called a saturation temperature, and what that is at any given pressure, there's a temperature that refrigerant is saturated, which means could mean 90% liquid, 10% vapor, or it could mean 10% 10% vapor, 90% liquid. Doesn't matter. All it means it's not 100% liquid or not 100% vapor. What superheat is how much warmer the refrigerant is than that actually saturated temperature. So where you want to measure your superheat is on the line coming into the compressor, your suction line. And all you do is you put your gauges on the unit. You know what your low pressure is, your suction pressure. You'll need some type of a chart. Some gauges have it right on the gauges. You cross-reference that number. So say it's 80 pounds, R410. You look over what that number might be. It might be 35 degrees. You measure your actual temperature with a thermometer, and it will be hopefully higher than that. And the difference between the two is your superheat. With a small, like the 5/8 line like that, it doesn't really matter. That's more if you're getting to larger refrigerant lines, 2-inch. The only reason for that is you don't want it to go on the bottom because that's where the oil is. But in this, no, it doesn't really matter. Okay, this is subcooling, and subcooling follows the same idea, except it's what you're trying to figure out is how much. What you're measuring now is the refrigerant when it's in a liquid form, and you want to make sure that it's well into its liquid form. And what you're going to be looking at is your discharge pressure. Looking at the same chart, take that pressure, cross-reference it to the temperature, and the number you have on your liquid line. And the best place to measure subcooling is right at where your freeze protection thermistor is, right before the copper line goes into the expansion valve. That's as good a place as any to measure it. So what you want to do, take your pressure, cross-reference it to a temperature, take your actual temperature with your thermometer, and the difference between the two, and your number should be lower, probably anywhere between 10 to 20 degrees lower, and that gives you your amount of subcooling. And subcooling is very important. The more subcooling you have, the more refrigeration effect you have, the longer it'll take for that refrigerant to turn into a vapor, more latent heat, and latent heat that's everything when it comes to refrigeration. That's what's doing your work. So subcooling is very important. And an indication of poor subcooling could be if a unit's low in charge, you'll have very low subcooling, possibly no subcooling. If a unit's overcharged, if you put too much gas in it, that means you've flooded the evaporator with liquid and you're going to have way too much subcooling. So all those charts are in your IOM books, manufacturer specs on temperatures, subcooling, superheat. So TX valve. TX valves in our units are not adjustable, and from my experience, TX valves really never need to be adjusted. I don't think I've ever adjusted one, and when I have, I've always made it worse, so that's why they do that. All the TX valve, there's a spring in the bottom, and it works off spring pressure, and if you've noticed on those units, there's a little copper bulb fastened to the suction line. Well, that bulb has a refrigerant charge in it. I'm not sure what type of refrigerant, they're all different, but so what it does is that senses the temperature of your suction line, and because it's full of refrigerant, that temperature will indicate a pressure. That pressure will open your TX valve. See right here? It'll force that piece down, allowing more refrigerant through the TX valve and into the evaporator. And as that temperature starts to fall on your suction line, that TX valve is sensing that there's enough refrigerant or possibly too much refrigerant going through. The pressure will drop in that bulb because the temperature's lower, lifting that up and throttling off the amount of refrigerant going in. So it takes a little while, usually about 5 minutes of runtime before that TX valve actually settles into a proper pressure or temperature. It just hunts for about the first 5 minutes. That's why when you first put your gauges on a unit, you might see the pressures moving around a little bit on your suction side. That's because that TX valve is, it's kind of hunting, looking for its comfort spot. Okay. Did you guys get the handouts, those forms? What those forms are for is, those are going to be startup procedures now. And what's going to happen is you're going to get that with every heat pump, and you're going to fill that in, all the pressures, all the temperatures. You're going to send that back, and what that's going to happen is it's going to trigger your warranty, and it's also going to go into a database, like a spreadsheet we'll have here, and it'll be pulled up based on the serial number. So if you guys call in year and a half down the road, that same unit's not working properly, I can get the serial number. I'm going to pull up your startup form that you sent back, and I can look at all your temperatures and your pressures that you had on startup, and it'll help pinpoint where your problem is and see where something possibly has changed in the unit. And not only that, we know that worked properly from the beginning, so something has changed. So start off here, that's your suction temperature. You can measure that anywhere close to the compressor's fine. Just peel back a little bit of the insulation, put your, and we're gonna also provide in the near future a thermometer. It's gonna have six different ports on it. So you can hook it up to the unit while it's off, no power to it, stick your hands in there, mount all of your different sensors, turn the unit on, and one by one you can scroll through and get all your different temperatures, and you can do that while you're filling out this sheet.